Okay, we're on page 174, and this is a really important page because this will be the first time I've introduced to you some of this, how to make graphs, and there's some important stuff here to pay attention to. The math isn't too crazy hard, but this is a video that you might want to watch twice. It would really help you with your homework. Um, so again, probably watch this twice. Question A reads, copy the table from Explore Activity 1 that shows the amounts of ammonia and distilled water. And I'll remind you that we learned that for every one, we learned this, I'll do it off the left, for every one ammonia, there's 50 waters. So we can use that math there to figure out that if we had 2 ammonias, it'd be 100 waters, 3 ammonias would be 150, 4 ammonias would be 200. This one right here is 175. We talked about that on the previous page. So let's move on. Question B reads, write the information in the table as ordered pairs. This is a new term for us, ordered pairs. It says use the amount of ammonia as the x coordinate and the amount of distilled water as the y coordinate. So what that's saying here is that the ammonia is going to be the x value, and that goes first. And so I want you to notice that this 2 right here on this table is the first number in the ordered pair. So check out the whole pair though. It's 2 and 100. And in the next column over, it's 3 and 150. So this will be 3 comma 150. So now you know how to write those. All of the x values are going to be the first number in the pair, and all the y values are going to be the second number in the pair. So this is going to be 175. This is going to be 4. And then the question reads, graph the ordered pairs. Because fractions and decimals can represent amounts of chemicals, connect the points and describe your graph. So I'm going to go ahead and I think what I'm going to do here actually is take a picture of this and enlarge it just a little bit because it's kind of small. You'll be fine just to graph it as is, but I'm going to make mine just a little bit bigger. I'll end up using this later as well. So what I'm going to do here is I'm going to use all of these pairs right here to graph these points. And I want you to notice they did one for us. This one right here, 5, 250. That's from right here, 5, 250. And how they got that was they started at 0, and the first number 5 means to go over 5 on the x-axis. So that's right here. And the second number, 250, means to go up 250 on the y-axis. So notice this 5 right here is 5 on the x, and this 250 right here is 250 on the y. So we're going to do the same thing with all the other ones. The first one is 2 comma 100, means over 2 up 100. The third one is 3 150, that means over 3 up 150. Next one is, I'm going to skip that decimal one for a minute, and I'm going to do over 4 up 200. And I think you should notice a perfect pattern there. Now that one I skipped is just over 3.5. There's 3, there's 4, 3.5 is right in the middle, so I'll go between. If I go straight up to about 175, you can see really a perfect line there. I'm actually going to use a line tool to make a perfect line, because it asks us to connect the points. The directions say connect the points. So I made a perfect line there. And to describe your graph, we could just call it a straight line or even just a line. That's all you need to do there. All right, so what I'm going to do here is I'm going to take a picture of this because I'm going to need it for a later question. I don't need it right this minute, but I'll need it later. So now what I'm going to do is clear and move on. I'm going to put this off to the side. I'll use it later. Okay. So we're on question C. Question C reads, for each ordered pair that you graphed, write the ratio of the y coordinate to the x coordinate. This is pretty important. We're writing a ratio of the y to the x. So if you went up and looked at your table, the first pair was 2, 100. So a lot of kids would want to write 2, 100, but it says to put the y first. Like if you went back to your table, it says the second column, the bottom row, is the y values. So the first answer here was 100 over 2. And I know that might seem backwards, but we're simply following the directions where it says put the y to the x. And I'm going to use this as a fraction. So the first one I'm going to write is 100 to 2. The next one we graphed was, it was 150 on the y value, and it was 3. The next one we graphed was, it was 175 as the y value, and the x was 3.5. And And the last one we graphed was 200 on the y value, and it was y. The x was 4. And the last one was given to us. It was 250 to 5. Now there's a reason why we're going to write it like that. We'll get to that in just a minute. Question D reads, the ratio of distilled water to ammonia is blank to 1. Well, we knew that from even the previous page. It's 50 to 1. It says, how are the ratios in C, all these answers we just got, related to this? Well, let's just go look at those. This one, how is that related to 50 to 1? How is this one related to 51? I hope you're thinking that they are equivalent. That's the word that should pop into your brain. They are equivalent. They're all equivalent. Question E says, the point 2.5, 125 is on the graph, but not in the table. The ratio of the y to the x is blank. Well, it's the numbers they just gave us. The y in that pair is 125 because the second value is the y. The x is the first value, it's 2.5. So the answer to this space right here is 125 over 5. And then it says, how is this ratio related to the ratios in C and D? Well, what is your guess? Is your guess is that it's equivalent, or is your guess that it's not equivalent? So only one way to check. We could simply check using math. How could we check to see if that's equivalent? So off to the side here, I'm going to write 125 over 2.5. And I'm going to put equal question mark because I don't know if it's equivalent. And I'm trying to figure out if it's equal to 50 to 1. We decided all the other ones are equal to each other. What about this one? This is a great one for cross multiplication. Remember, cross multiplication means that if you multiply this direction, the product has to be equal to if you multiply this direction. This direction is obviously 125. 125 times 1 is 125. Is 50 times 2.5 equal to 125? Really easy to check with a calculator. 2.5 times 50 is 125. We already proved that 125 times 1 is 125. So what does that mean? It means that it too is equivalent to all the other ones. And then this is kind of a follow-up. It's in that same question right there. 2.5 mil of ammonia. 2.5 is the same as that. So this is saying 2.5 mils of ammonia requires blank mils of water. Well, I hope you recognize that it's simply the partner, so it's 125. Question F, what do you think is true of every point on the graph? Well, all the points we put on the graph were equivalent to 50 over 1, and even this one that we just checked out, 2.5, 125, is equivalent to 50 to 1. So what do you think is true of all of them? I think what's true of all of them is that they are all equivalent to 50 over 1, or I'll use a colon in this case. Okay, we have one more question to do, and this is the one I wanted to save this image for. So I'm going to go ahead and scroll down the page. Go ahead and clear the annotations. Scroll down the page here. And my image right here is going to really help me on question 2. Question 2 reads, how can you use the graph to find the amount of distilled water to use for 4.5 mils of ammonia? So 4.5 mils of ammonia would be down here. This is the ammonia point, the ammonia axis. And I know that this right here is 4, and the 4.5 is just going to be a little bit past it. So if I go to about right there where I'm hovering, that's 4.5. So how can I figure out the amount of water needed? Well, what I'm going to do here is I'm just simply going to kind of look all the way up to where it crosses this graph. And you can see it would cross the graph right around here. Now that's not an answer. How can I get my amount of water? Well, I then look over here, and that looks to be about midway between 200 and 250. Midway between 200 and 250 would be about 225. So I would say about 225 mils of water. Now that doesn't actually answer the question. The question says, how can you use the graph to find the amount of distilled water? Well, what I would say is this. I'll type it. What I just did, what I tried to show you was this. Find 4.5 mil. I'm just going to say find 4.5 on the x-axis, comma, look up to the graph, and by the graph I mean the line, comma, you know what I'm going to say? I'm going to revise this. I'm going to look up to where it is on the graph, comma, then look left to the y-axis. That is the value. Now those words aren't super clear. I realize that I'm a little bit limited in how I can explain that. But what I just showed you, I'll highlight again, what I just showed you about looking from here up to there and then going over to the y-axis, that's how you do it. It's just hard to explain.